So circles homework here. Question 1, find the coordinates of the midpoint of AB. Well, that's fairly easy. Use the midpoint formula. You know the midpoint is going to be x1 plus x2 over 2 and y1 plus y2 over 2, and that's a coordinate. B stands for A. B says find the slope of AB. Well, you know that slope equals y2 minus y1 over x2 minus x1. And then C says C, verify that OM, or OM is this one here, verify that it's perpendicular. So you find the slope of OM, and if it's a negative reciprocal of the slope in this bit here, then they're perpendicular. Question 2, verify the points P, Q, and R are equidistant from C, which is 2, 2. And we're going to do that by the distance formula. So you find the distance formula of each one, and so from P to C, and P to Q, and P to R, and find those three distances. If those three distances are equal, then you have proved that they're equidistant. Okay. Draw the circle that passes through P, Q, and R. So just do a sketch of the circle. Question 3 here, verify the points A, B, and C lie on a circle with its center. Well, the way you verify this is by doing the same thing. Find the distance A to D. So AD, find that distance. Find the distance BD, that's another outside the circle to the center of the circle, and find the distance CD. So you're going to find those three distances. This is for 3A, and if they're equal, then the points lie on the circle. Determine the length of the radius. Well, the radius will be B. The radius will be each of these three lengths here you found in A, CD, BD, or AD. Plot points A, B, C on grid plan. Draw the circle that passes through the points. Use a drawing to check your answers for A and B. Well, it's quite easy to do. Question 4, verify that the points E, F, G lie on a circle with its center. With the same thing, find the distances EH, FH, and GH, and do the same thing. Question 5, verify the center of the circle lies on the right bisector of the chord PQ. So we're going to find the midpoint of PQ, midpoint PQ. We're going to find the slope of PQ. And wherever that midpoint is, it might be there, we're going to call it, say, the letter M. And then you're going to find that OM, slope of OM. And if the slope of OM is a negative reciprocal of slope PQ, then it is on the right bisector of chord PQ, which is exactly what the theorem says about a chord and the circle. Question 6, explain how you know the origin is the center of the circle defined by the equation x squared plus y squared equals 45. Well, of course, the origin is given by the circle x minus h squared plus y minus k squared equals 45 is the formula for the circle, and when h and k are 0, we get x minus 0 squared plus y minus 0 squared equals 45. Well, x minus 0 is just x, and x squared is that. Y minus 0 is y, so we'll square it y, and that's how we get the equation. Verify the points 3, negative 3, 6, and negative 6, 3 lie on the circle. Where we substitute those 2 points into that equation, and it should be an equation that equals 45 equals 45. Verify the line through the origin and the midpoint of the chord, or S is the perpendicular to the chord. And for C, you can do exactly as you did in question 5.